All right, we're getting reasonably close to the end of the chapter, and this video I'm sure I'm going to do in two parts. The first half of section 1.4 is an algebra kind of application, and the second half of 1.4 is kind of turning the algebra into calculus, and I want to separate those into two separate videos. In my college algebra class, I do problems like this. So this is the first, I don't know, dozen or so problems, maybe the first 15 problems in this section are all problems that you may have done in Math 151, but you probably would have only done those in one part of one section, so you might not remember them. So the first 8 problems give me a function, and they give me two values for x. The instructions say find the average rate of change over the given interval, and then sketch a graph to model your answer, and then I may use my calculator to get a reasonable graph because I don't want to worry about spending a bunch of time making a good graph. So the average rate of change is simply the slope of a line that connects 2 points. So for each of the problems between 1 and 8, since I'm asked to find the average rate of change, I need to know that that's the same thing as the slope of a line that connects 2 points. So I would have the formula y2 minus y1 over x2 minus x1. Let me give a picture of this function and the line that we're trying to find the slope of. So I'm going to sketch a graph. What a horrible first problem because the vertex of this is going to be a fraction. I'll live with that. So let me borrow my calculator. I'm going to sketch a graph. I'm going to do zoom standard, and I'm going to label the vertex of my parabola, and I'm going to label 2 more points. My graph is not going to be stellar by any stretch of the imagination, but just because it's a parabola, I like to label the vertex, and it's because it's easy to find the vertex on my calculator. And I'm going to make two more points. So this graph that I'm asked to sketch a graph to model my answer, I'm going to label, let me see, 1, 2. I know that I'm going to have a point above x equal to 3. And I know I'm going to have a point above x equals 4. It's going to be a parabola. I'm going to label the vertex and 2 more points. And I'm going to use my oh, you can't see what I just did. I'm going to use my calculator to get a graph. And I have to bring this down, otherwise you can't see anything on my graphs. I'm not even sure that you're going to see anything when I do this. So clear y equals clear, and now x squared minus 5x plus 2 zoom standard. This is a picture, just a generic parabola. I'm going to find the coordinate of that vertex. That's another thing you do in college algebra. That vertex is a minimum point. To find the vertex on my calculator, I hit the second button, the trace key, select the minimum option, and then I start tracing. I trace and get kind of close to the vertex but to the left of it. And then I trace further. I get kind of close to the vertex but to the right of it. And then I get as close as I can to the vertex, hit enter, and it's going to tell me what the vertex is. Well, I'm going to round that 2.4999 number to 2.5 because my calculator, once it gets close enough to the vertex, it actually stops. So I believe the vertex is at the point 2.5, negative 4.25. So the first point I'm going to plot is 2.5, which is about there, and then negative 1, negative 2, negative 3, negative 4, negative 4.25, and let me do that in a different color. So my first point, 2.5, negative 4.25 is the vertex. The other 2 points that I want to have, I don't need that accurate of a graph, but I want the point that has x equal 3 and a point that has x equals 4 to be shown on my graph, because these are going to be important in this particular graph. So I'm going to hit second, calc, go to the option that says value, type the number 3, and hit enter. That tells me the point 3, -4 is going to be a point on my graph, and that's going to be an important point on my graph. So the point 3, -4. So the vertex was the point 2.5, -4.25. This point's the point 3, -4. And then the last point that I'm going to draw on my graph nicely is at x equal to 4. So I'm going to go second, calc, hit enter on value, type in 4, and hit equals. And all my calculator is doing is plugging 4 in for the function and figuring out what the y you get. Now I get y equal to -2. So that's 4, -2. And now I'm going to draw just a parabola. It's not a terribly wonderful graph, but it's okay. I didn't really even go through the points that well. So there's a graph. Real quickly, if you didn't want to use your calculator to get the points, for that 4 right there, all my calculator did is plug 4 in for x. It did 4 squared minus 5 times 4 plus 2, and that's 16 minus 20 plus 2, and that's -2. So you can get the points without using your calculator, but since I had it out, I'm going to exploit my calculator's ability. So pictorially, what I'm trying to find, the average rate of change between x equals 3 and x equals 4 is the slope of the line that connects these 2 points. So this is pictorially what I'm finding. So I drew a line that went through the point 3, -4 and 4, -2. The average rate of change is the slope of that line. It's not terribly hard to find the slope of that line. I just have to call one point the first point, the other point the second point, and I'll find the slope. So I have 2 points. The first point I found, I'm going to call that the point x1, y1. I'm going to call that 3, -4. The second point that I found, 4, -2, I'm going to call that point x2, y2, which is 4, -2. And then the average rate of change is going to equal to y2, which is -2, minus y1, which is -4, over x2, which is 4, minus x1, which is 3. In the numerator, this double negative turns positive, so that turns into -2 plus 4, which is positive 2. The denominator is 4 minus 3, which is 1. So the average rate of change is going to be 2. So somewhere I'm kind of out of room down there. So my answer to problem 2 is the average rate of change equals to 2. So that's completely an algebra problem. There's not a lick of calculus in there, but it's going to connect us to the calculus that we're going to do in the second half of this section. So each of the problems between 1 and 8, I'm going to do exactly this procedure. I'm going to use my calculator to sketch a graph and label. Since this was a parabola, I just had the urge to label the vertex because it made the graph a little more accurate. I'll label at least the 2 points that I need that are called out by the function, and draw the graph, draw the line that connects the 2 points, and find the average rate of change. So problems 3 and 4 are square roots, and square roots graph like half parabolas on their sides. I kind of already know what this graph looks like, but I'll pretend I don't, and you don't at this point have to know much about what a graph looks like. So I'm going to go ahead and sketch this. And I know that it's going to be important to me at a minimum. I'm going to want to have a point labeled above x equal to 2, and I'm going to want to have a point labeled above x equal to 7. I know that square roots, you find the domain of a square root by just taking the radicand and setting it greater than or equal to 0. So the domain of this graph is going to be x is greater than or equal to -2. Another thing you do in college algebra and intermediate algebra. So the graph is going to start at -2. So when I started marking out my x-axis, I knew ahead of time what my calculator was going to show. And I think sometimes on square roots, my calculator does a less than perfect graph, and I'll improve my calculator's graph. So now I'm going to graph this the best I can. So I'm going to turn my calculator on, hit y equals, clear the function that's in there, hit second, and then the x squared key to get the square root, and then x plus 2. I think Zoom Standard is going to be well enough here. Yeah, it did perfect. So right there's where the graph starts, and I want to I'll label that point, that's the point -2, 0. I won't need that point for anything, but it can't hurt to have it. And then the other 2 points I'm going to plot are when x equal to 2 and x equal to 7. So I'm going to go second, calc, value, x equal to 2, and hit enter. So that tells me one of the points I'm going to need to plot is the point 2, 2. That's going to be an important point because I'm going to use that point to find the average rate of change. And lastly, I'm going to plug in 7. I could do that by hand. I could just go f of 7 equals the square root of 7 plus 2 equals the square root of 9 equals to 3. So I should get 7, 3. Or I could use my calculator and go second, calc, enter on value, type in 7, and it'll tell me that the y is 3. So here's sketching a graph. And the average rate of change is the slope of the line that connects these 2 points. So what I'm trying to find, my graphs aren't stellar, they're good enough, I guess, because eventually this line doesn't track the function so well. But the average rate of change is what I just drew in blue. And so that's the graph that I'm asked for, and now I'm going to finish up by finding the average rate of change. I need 2 points. I'm going to call the point x1, y1, the first point I found, which is the point 2, 2, and x2, y2, the second point I found, which is 7, 3, and then the average rate of change is going to equal y2, which is 3, minus y1, which is 2, over x2, which is 7, minus x1, which is 2. That's 1/5. And that's the slope of that line. That slope is, you go up 1 over 5 to get from one point to the next. So the slope is up 1 over 5, and you move from point to point. So my answer, if I just want to write the numerical answer, not write the words average rate of change, that's going to be fine if I can actually write that. So you should be able to take a shot at 3. At some point this semester, you're going to need to have a graphing calculator, and I don't want you at this point to have to struggle to do graphs by hand, so you want to get that calculator as early in the semester as you can. Six gives me a nice exponential function, and I'll make a stab at graphing it. Exponential functions, the graphs, they don't have a starting and a stopping point. I don't know that I'm going to and they don't have any vertexes. I think I might just label the 2 points and borrow a graph from my calculator. So I can't graph 3 to the t on my calculator, but I can graph 3 to the x. So I'm going to turn my calculator on, get to the graphing mode, y equals, clear, 3, and then the up arrow key over here, and then to the x. That standard window is probably just fine, so I'm going to leave it at that. And there's a graph. The part over here, it looks like there's no graph. You graph these in college algebra as well. The graph continues forever, and it just stays microscopically above the x-axis. Let me get the points that I need, because I need a y value for the point above 0 and a y value for the point above 1. So I'm going to do second calc value, type in 0, and that's going to give me the point 0, 1. And then second calc value, type in 1, that gives me the point 1, 3. So I'm just going to plot those 2 points and make a graph look more or less like I see here on my screen. So I'm going to plot the point 0, 1 and the point 1, 3 and draw an exponential function. The graphs of I should be doing that in black. The graphs of exponential functions shoot up real high quickly, and on the one other side, they usually get really close to the x-axis. So this is a reasonable picture. You definitely won't have to do better than this on a test. And now I'm going to draw the line that I'm finding the average rate of change, or the slope of. So there would be the line that I'm asked to find. That line is the average rate of change between those 2 points for that particular function. So now I'll just finish this up. The average rate of, and usually instead of writing the word change, I make a triangle to represent change. It's going to be y2, my y2 is 3, minus y1, my y1 is 1, over x2, which is 1, minus x1, which is 0. This is 2 over 1, so my answer is going to be the average rate of change is 2. One more before we get to some word problems. So hopefully you're just pausing the video and doing the odd problems. All right, this is going to be a nasty graph. Well, maybe not so nasty. So graphing the ln of t. Natural logs, graph those in college algebra as well. I'm just going to borrow a graph from a calculator. This graph is going to, I know the domain of it already. It's going to only exist to the right of that line, because you find the domain of a logarithm graph by just taking the argument and setting it greater than 0 as opposed to greater than or equal to 0. So this function's only going to exist kind of to the right of the y-axis. I'm going to sketch a graph, and I'm going to find 2 points. Ooh, they're a little bit harder to find. Well, not on the x-axis. So one is here. E squared, I better find out what that is before I commit to my graphing. So I'm going to go second and ln. That gives me, whoops, second quick. Let me get to the main screen. To find out what e squared is, I hit second and ln. There's the e, and then I hit squared. And e squared is 7.38, 7.39. So I'm going to mark e squared somewhere between 7 and 8. So as I'm marking out the x-axis, 1 was a value that was given. And e squared is a value that's given. So e squared is about, probably a little bit over there more, but e squared is about there. All right, so let me get the graph and get the y coordinates of my points. So graph y equals clear. I can't do ln of t. I'm going to hit the ln button and do hit the ln button and do ln of x. My standard window is probably adequate, so I'm going to graph it. And similarly, the graph here, it plunges down forever. It doesn't stop. It basically stays microscopically to the right of the y-axis and goes down forever. I find the points that I need to have. So I need to get the point 1 comma something and e squared comma something. For the 1 comma something, I'm going to go second calc value, type in 1. It tells me it's the point 1, 0. So I'm going to mark that point here in a second on my graph. And then second calc value e squared, I go second and then hit the ln key and then type a 2 for e squared. That gives me 2. That would have been a little bit trickier to do by hand. If I wanted to find that point, I'd go the ln of e squared. And of course, you know that that's the same thing as 2 times the ln of e, because when you have a logarithm, you could bring the exponent outside. And a fact that we had from college algebra that we're going to use a lot this semester, the ln of e is 1. So this is 2 times 1, which is 2. So those are the 2 points I need to plot, and then I'm going to more or less just copy this graph. So I'm going to plot the point 1, 0, and then e squared comma 2. So e squared comma 2. And then more or less just copy this graph, except I'm going to make the graph plunge down at the y-axis and not cross nor touch the y-axis. The graph really should look more like that than it does on my calculator. And then I'll pull out another color for my average rate of change. So my average rate of change is going to be that. So there's the picture that I was asked to come up with. And now the algebra. So average rate of change equals y2, which is 2, minus y1, I don't know why I did a parentheses there, but it's not wrong to have it, over x2, which is e squared, minus x1. It's going to be 2 over e squared minus 1. That's a beautiful answer. If you want to, you can leave that as your answer, or you can give a decimal equivalent. There's no way to simplify this without pulling out my calculator and giving a decimal. So a perfectly good answer to what the average rate of change is the fraction 2 over e squared minus 1. That's the slope of that line. And I'm going to put a 2 decimal equivalent, so I put a little squiggly line saying I'm going to give a rounded version of this. To get a rounded version of this, I'm just going to go second and quit, clear this out, and go 2 divided by parentheses, second and ln, e squared minus 1, close out the parentheses, and that's about 0.313, so I'm going to do 0.31, just because I'm giving 2 decimals. Alright, so that's probably about a third of the section. You should make a stab at doing number 7. The next group of problems are going to be word problems, and they're not particularly hard. They're actually exactly the same things. We don't have to take the time to do a graph, which is really nice. And we just, from the problems, are going to have to extract points. So in each of the word problems that are in this middle group of problems, somewheres in the problem we're asked to find an average rate of change. And if I'm asked to find an average rate of change, I need to have 2 points, because an average rate of change is a slope of a line that connects 2 points. Each of the problems, the word problems, are worded in such a way that the points are just there for you. And as I read through the problem, I'm going to pull out the numbers that relate to each other and create points. So as I do number 10, a scuba diver is 30 feet below the surface of the water at 10 seconds. I'm going to create a point with that bit of information. So the x-coordinate of the point is going to be 30 feet. And I usually don't write the units, but I will here for the first problem. And the y-coordinate is 10 seconds. Usually, if we have, this is called a position function, tells me what its position is relative to a time, and the position comes first. So that would be my first points, 30, 10, or 30 feet in 10 seconds. And then after you enter the water and 100 feet below the surface after 40 seconds. I don't know anything about scuba diving. That seems like a ridiculously fast descent to go 70 feet in 30 seconds. It's probably dangerous. So if you're into scuba diving, you can tell me if this is a ridiculous problem in terms of that's going down way too fast. So those are my 2 points. Now I can find the average rate of change. So the average rate of change is equal to, oh gosh, change in y over change. I said something backwards here, and I don't want to re-record my whole video. It would be better, but not wrong, but it would, the way I labeled the points here is actually kind of backwards from how I really want them to be. So let me, wish I could rewind it and scratch what I said. When we're labeling points that have time as one of the components and distance as the other component, it's probably better off to label my x coordinate as time and my y coordinate as the distance or the position. So I'm going to change these points. Sorry about that. This gets to just being a little bit rusty. I actually haven't done calculus lectures since, it's either 1998 or 1999, but a boatload of time ago. So there's a little bit of rust here, and every now and then I wind up just re-recording a video because I'm just that rusty and I wasn't happy with my first shot. So I should have, for problem 9, even though the information was given with the distance first and the time second, it's better to do time first and distance second, just because of how the average rate of change, what the average rate of change says when you compute it. So with this version, if you'd have had the points like I had them, you'd have got a different answer for mine. It wouldn't have been incorrect at all if you put the units to your answer. So I'm going to put units in all my answers to these word problems, so that if you label your points different than mine, if you put the units in, your words will be right. So my average rate of change, so my average rate of change is going to be the second y, which is 100 feet, minus the first y, which is 30 feet, over the second x, which is 40 seconds, minus the first x, which is 10 seconds. This gives me 70 feet is the net distance. They went from 30 feet to 100 feet, so they traveled 70 feet in 30 seconds. So the zeros cancel, and I get 7 over 3 feet in the numerator, seconds in the denominator. And usually we would change that and we'd separate the units from the fraction. Oh, you can't see what I'm writing. And I'm going to change the feet in the numerator and the seconds in the denominator and separate them from the number and put the word per between them. So my average rate of change is 7/3 feet per second, or you could say it's 2 1/3 feet per second would be fine too. And you can even do 2.33 feet per second. But that makes more sense to me, that I'm moving at 2 1/3 feet per second. In the reversed, seconds per feet, although maybe that makes sense, it doesn't sound as good. Usually, like if I'm moving, I'll tell you how fast I'm going in miles per hour, or feet per second here. So usually when the average rate of change has time as one of the components, the time should be the x component, and then your answers will be more kind of in line with what people usually, when they refer to average rates of change that involve time. So you should maybe make a stab at number 9. And we'll do 11 and 12. 11 is more like problem 9. When you go to make your oh, there's a trick in it though. When you go to do number 11, you're going to make the x coordinates the time, and the y coordinates the distances, or the positions. The times here are conflicting, one's in seconds, the other's in minutes. You could either make 2.5 minutes into seconds. Oh, you have to, because it says what is the rate of change in miles per second. So when you do problem 11, you need to change 2.5 minutes into seconds. And to do that, I go 2.5 minutes times 60 seconds is 1 minute. And I cancel out the minutes. And then 2.5 times 60, I'm doing off screen on my calculator because I don't think I can do that in my head right now. So when you go to do problem 11, the times have to be 30 seconds and 150 seconds. The distances are okay because I'm asking what's my average rate of change in miles per second. The distances have to be in miles, which they were. The times have to be in seconds, which one of them was and the other wasn't. In problem 12, I'm going to be consistent, and I'm going to make the time the x's and the other units the y's. So I'm given information for points. A teacher weighed in 1996 160 pounds, and in 2013 210 pounds. Fortunately, it's not me. I may have weighed 160 in 1996. I think I probably weigh like 165 today. But anyways, for my average rate of change, I need to make points. And my points is going to be in the year 1996. The weight is 160 pounds. And in the year 2013, it's 210 pounds. And so my average rate of change is going to be the y2, which is the 210 pounds, minus y1, which is 160 pounds. And then the year 2013, I didn't know what I was going to write there. I could write year, minus 1996, which is another year. And so this comes out to be 50 pounds in, well, again, I'm going to do that off screen so I don't make a mistake on my video, over 17, and that's probably years. So the average rate of change, the answer, if I want to give a improper fraction, is the average rate of change is 50 over 17 pounds per year. And I would never say the average rate of change is 50 over 17 pounds per year. I'd probably figure a decimal version of that, but this is a correct answer. The instructions don't say give a decimal answer, so I would be safe and I'd always write the fraction answer down. So if you're not asked for a rounded decimal answer, always give me the fraction answer. You'll never take points off for that. But if you don't like the way that answer looks, you can parenthetically say this is about, and then the 2 decimal approximation is 2.94 pounds per year. So this teacher, on average, gained just under 3 pounds per year between 1996 and 2013 to gain those 50 pounds. So the average rate of change is the pounds per year. So the average rate of change is always something per something. And now you can make your stab at number 11 if you haven't already done it. As I look at problem 13, I really despise it. let's just skip it. I don't want to re-record my video to make a new problem 13. So skip that for homework and don't even worry about it. I'll do problem 14 real quickly. As a matter of fact, let me skip problem 14 and move on to a page where we can do two problems together. All I was going to do for problem 14 is make 2 points. The time would be the x coordinate. And so the times are 4 weeks and 9 weeks. The y coordinate is the non-time component. That's the amount he has saved. So $300. No. Oh, bad, horrible problem. He had $350 after 4 weeks. So the times would the dollar amounts. There's a extraneous variable. So the points that I'm going to worry about. After 4 weeks, he had $350. After 9 weeks, he had $400. And if I wanted to finish this problem up, I'd find the average rate of change would be dollars per week. Dollars is going to be in the numerator of the fraction. Weeks is going to be in the denominator of the fraction. And the average rate of change in his money in dollars per week. The weeks is going to be in the denominator. The dollars is going to be in the numerator. I'm not going to do this problem just like you're not going to do 13. And we'll move on to 15 and 16. And then I'll stop the video and we'll do a part 2. So up through 16 is all the algebra part of section 1.4. And then the rest of section 1.4 is calculus, and we'll see the big connection between the average rate of change that we do in algebra and something called instantaneous rate of change that we do in calculus. So I'm going to do problem 16. So after 30 baseball games, A-Rod had 25 hits. If after 100 games he has 80 hits, what are his average hits per baseball game? So that means I need to form a fraction that has hits in the numerator and the number of games in the denominator, because I'm asked to find average hits per baseball game. So I need to create points that are going to give me hits per game. And, well, when I do my points, the y's are going to go in the numerator, so the y's have to be the number of hits, and the x's are going to go in the denominator, so the x's have to be the number of games. So the first bit of information, after 30 games, A-Rod had 25 hits, and then after 100 games, he had 80 hits. So the average rate of change is going to be the 80 hits minus 25 hits in the numerator. That gives me the hits in the numerator to get hits per game. And then in the denominator, it's going to be the 100 games minus the 30 games. This is 80 minus 20 is 55 hits that he got over 70 games. So the answer, again, a non-decimal round fraction answer, is his average rate of change is 55 70th hits per game. And again, I'm going to include a parenthetical what this is actually equal to, because 55 over 70 doesn't mean a lot to me. It's 0.78 or 0.79 hits per game, so it doesn't quite get a hit a game. So 0.78 hits or 0.79 per game. So for each of the problems that you do, give the fraction answer, and then you don't have to give a decimal answer, but if you feel the urge, because it feels a little bit better to say that, you're getting just under a hit a game, then go ahead and include that. But if you just give me the fraction answer, that's going to be enough.